Let's talk about column orientations. To know about column orientations, you should be well aware of this factor, which is I, the moment of inertia. And this is nothing but the second moment of area. For an example, let us consider a scale, a simple scale like this, which is being laid horizontally like this. The dimensions of the scale are assumed as the length is 300 mm, the width is 25 mm, and the thickness is 2 mm. If you try to bend the scale vertically, that is upward or downward, you can do it without any effort. It is going to be much easier. When the scale is rotated like this, if you try to bend it, it is going to be a little bit harder to bend the scale. We have not changed any material, just we have changed the orientations. The scale is offering more resistance to bending. This is because of this factor which we call as moment of inertia or second moment of area. We will see the same with an example and we will analyze the reason for that behavior. When the scale is like this, the cross section is, the B is 25 mm whereas D is 2 mm. So when we find the moment of inertia, assuming the scale's cross section as a rectangle, we get the value as 16.667 units. When the scale is in this fashion, when it is held vertically, the B and D are interchanged. The depth becomes 25 mm and width becomes 2 mm. And when we apply this, we get the value as 2607.1667, which is 156 times larger than this profile. This is the reason which contributes the resistance to the bending. As we know, in the bending equation, the moment of inertia commands the bending moment or the bending stress. So a change in this value will abruptly affect the moment induced or the bending stress induced in the member. With this in mind, we'll move on to the column orientation. We'll come to column orientation. To study the column orientation, we'll take an example of a hall which is 30 meters in length and 10 meters in width. The hall is divided into 10 equal bays. So let us study this column for column orientation. Assume that the beam which is on the right hand side of the column is being alone loaded. All the other beams are not loaded. So when the beam is loaded like this, what happens is the beam bends in this fashion because the beam is rigidly connected with the column. It is having a hogging moment at the support and a sagging moment at the midspan. This hogging moment at the support tends to rotate the joint and in turn tends to rotate or bend the column like this. Just assume that we are removing the load from the right hand side beam and we are applying the same load on the left hand side beam. So what happens? The beam is loaded like this, whereas it induces a moment on the beam like this and in turn rotates the joint and the column. Just imagine the beams on the either side of the column are loaded simultaneously. What happens? The beam is loaded like this. The moments are induced like this on both the sides of the column, whereas these two moments are nearly equal because they come from the same building, so they might have the same intensity. Since the span is same, they are going to have the same intensity more or less. So each of them are having separate orientations. One is clockwise and another one is anti-clockwise. So these two moments counteract each other and we won't have any moments acting on the column in this direction. So when both the beams are loaded, there ain't going to be any moment in the horizontal axis because the moments are going to be counteracted by each other, whereas the column has to take only the moment which is coming from the 10 meter long beam, so which doesn't have any beam to counteract the moment which is induced by this 10 meter beam. So when we want to orient a column, in the right hand side, it might be a little bit intimidating because it provides an option for us to hide the column inside the walls. But if this orientation is provided, it is going to orient the weaker side of the column towards the load. In the left hand side, you can see the depth of the column is oriented towards the 10 meter beam, which will offer a good resistance to the bending, and we have seen the reason with the scale example. So the left hand side orientation is the right one because it is going to provide us with the most economical design, whereas the right hand side orientation will provide a more uneconomical design of the column. So when we are concentrating on column orientations, this has to be kept in mind. Column's depth to be oriented towards the beam exerting larger unbalanced bending moment. When you are working on column orientations, qualitatively identify the bending moment of beam and columns, study the unbalanced moments, identify the maximum unbalanced moment from the beam and identify the beam from which it is coming, align the column depth in that direction, align the column's depth in that beam's direction. If you like this session, kindly like, subscribe and share. If you are interested in our programs, kindly visit www.nishskills.org. Thank you.